Welcome to Distributed Systems Interview Crashcasts, your go-to podcast for mastering technical interviews. I'm your host, Sheila, and today we're diving into a common question you might encounter in a senior backend engineer interview. Joining us is Victor, an experienced distributed systems engineer. Victor, thanks for being here.
Thanks for having me, Sheila. I'm excited to share my insights with the listeners.
Great. Let's jump right in. Victor, here's a question you might face in an interview. Explain the difference between synchronous and asynchronous communication in distributed systems.
That's an excellent question, Sheila. At its core, the difference between synchronous and asynchronous communication lies in how the components of a distributed system interact with each other.
Could you break that down for us, starting with the basics?
Certainly. In synchronous communication, the sender of a message waits for a response before continuing its operation. It's like a phone call. You speak, then wait for the other person to respond before speaking again. On the other hand, asynchronous communication is more like sending a text message. You send your message and can continue with other tasks without waiting for an immediate response.
That's a helpful analogy. How does this translate to distributed systems specifically?
In distributed systems, synchronous communication often involves a client sending a request to a server and waiting for a response before proceeding. This creates a tight coupling between the components. Asynchronous communication, however, allows components to send messages or requests without blocking their own execution. They can continue processing other tasks and handle the response when it arrives.
I see. Can you dive a bit deeper into the characteristics and use cases for each?
Of course, synchronous communication provides immediate consistency and is often used when you need a guaranteed real-time response. It's common in scenarios like financial transactions or real-time collaborative tools. Asynchronous communication, on the other hand, offers better scalability and fault tolerance. It's often used in scenarios where immediate responses aren't critical, such as email systems or background job processing.
That's interesting. What about the advantages and disadvantages of each approach?
Great question. Synchronous communication has the advantage of simplicity and straightforward error handling. If something goes wrong, you know immediately. However, it can lead to performance bottlenecks, especially in high-latency networks. Asynchronous communication shines in terms of scalability and responsiveness. It allows systems to handle more concurrent operations and is more resilient to network issues. The trade-off is increased complexity in managing the flow of operations and handling errors.
Could you provide some real-world examples to illustrate these concepts?
Certainly. A classic example of synchronous communication is a user logging into a website. The system needs to verify the credentials before allowing access, so it waits for a response from the authentication service. For asynchronous communication, consider a video streaming service. When you click to watch a video, the service might asynchronously send analytics data about your viewing habits without waiting for a response. This doesn't block your video from playing.
Those examples really help clarify the concepts. Now, let's explore some edge cases. How would you handle a scenario where you need both immediate consistency and high scalability?
That's a challenging scenario, Sheila. One approach could be to use a hybrid model. For instance, you could use synchronous communication for critical operations that require immediate consistency, while offloading non-critical tasks to asynchronous processes. Another strategy is to use event sourcing and CQRS, which stands for Command Query Responsibility Segregation. This allows you to handle commands synchronously for consistency, while updating read models asynchronously for scalability. Essentially, it separates the part of the system that writes data from the part that reads data.
Excellent answer, Victor. As we wrap up, what are some common pitfalls that candidates should be aware of when discussing this topic in an interview?
One common pitfall is oversimplifying the trade-offs. It's important to acknowledge that neither approach is universally better. The choice depends on the specific requirements of the system. Another mistake is forgetting to discuss error handling and retry mechanisms, especially for asynchronous communication. You should be prepared to talk about how you'd ensure message delivery and handle failures. Lastly, candidates sometimes forget to mention the impact on system design. The choice between synchronous and asynchronous communication can significantly influence the overall architecture of a distributed system.
Those are great points, Victor. Any final tips for our listeners preparing for interviews on this topic?
Absolutely. First, make sure you understand the core concepts thoroughly. Practice explaining them in simple terms, as you might need to do in an interview. Second, have some real-world examples ready. Being able to relate these concepts to practical applications demonstrates depth of understanding. Finally, be prepared to discuss trade-offs and design decisions. Interviewers often want to see how you think through complex problems, not just recite definitions.
Fantastic advice, Victor. Thank you so much for sharing your expertise with us today. To our listeners, I hope this episode has helped you prepare for your upcoming interviews. Remember, understanding the differences between synchronous and asynchronous communication is crucial in distributed systems design. Practice articulating these concepts clearly, and you'll be well prepared for your interview. Until next time, this is Sheila, signing off from Distributed Systems Interview Crashcasts.